All right, here's the video key. Oh, never mind. God dang it. Oh, that's right. Okay. You guys want to say hi?
Hi.
Okay, good. All right, I'm doing this in study hall, so here we go. 16 to the negative 2/3 power. How do you deal with that? Well, change it to a radical. These are all no calculators, so if I change that to a radical, whoa, watch out, I need a pen. That's going to be the square root of 16 to the negative 3rd power. Square root of 16, you know what that is? 4, good. 4 to the negative 3rd power. You know what negative 3rd power means? Negative means you flip it, and then you take it to the positive power. So that's 1/4 to the positive 3rd power. So when we're all said and done there, that's going to be 1 over 64. Put all the answers in blue. 1 over 64. Final answer number 1. Number 2, we have log at 125 base 5 on the bottom and 125 to the 2/3 on the top. So we have a whole bunch of crazy exponents and logs and stuff. 125 to the 2/3, that's the same as the cube root of 125 squared. So if you have the cube root of 125, that's going to be 5. And 5 squared is 25. So my numerator is going to be 25. Cube root of 125 is cube root of 125. All that stuff is 5. 5 squared is 25. Ole, quiet down back there. I'm trying to make a video recording. Thank you. Log of 125 base 5, what does that mean? Well, you should know here, as you learned in this unit, that means 5 to what power equals 125. So 5 to what power equals 125? That's going to be a 3. So my final answer there is going to be 25/3. I'll just leave it as an improper fraction. All right, this next one here we have power to a power. So if we have a power to a power, we're going to multiply the fractions together. So in this case, I have 9 to the 2/3 to the negative 3/4. So I need to multiply these two exponents together. So what is 2/3 times negative 3/4? So that's going to be negative 6 over 12, which is negative a half. So that's the same as 9 to the negative half power. And to the half power means you square root. So the square root of 9 is 3. But it's negative 1/2, so it's not 3, it's going to be 1 over 3. So final answer number 3, 1 over 3. Number 4, log of 1 base 7. 7 to what power equals 1? It's going to be 0. Okay. Evaluating logs here again. 4 to what power is 256? You could look at your little handy dandy table of powers chart, or you just know that 16 squared is 256. So that would be 4 to the 4th power. So 4 to the 4th power is 256. Next one is a little bit trickier. This is going to be when you rewrite it as an exponent. 81 to what power? I'll use a variable this time. So 81 to what power is equal to 27? Okay, in this situation we took these and we rewrite these with the same base. So they're both a power of 3. So 81 is actually 3 to the 4th, so that's like 3 to the 4th to the x. And 27 is like 3 to the 3rd. So now when we write it this way, we can set the exponent stuff equal. So really I have 3 to the 4x is equal to 3 to the 3rd, and so that will be true when 4x equals 3. So when does 4x equal 3? Well, you could write a little equation just to be sure. Divide both sides by whatever is multiplied by x, which is 4, and you would get a final answer here of x equals 3/4. So there we go, number 6. Number 7. 0.5, if we see the base as a decimal, rewrite it as a fraction. So this is going to be 1/2 to the unknown power x is equal to 2. So how do I make a 1/2 into a 2 using an exponent? Well, if it's a negative, it flips it, and that's all I need. So in this case, x is equal to negative 1. You could rewrite those with the same base. How can I rewrite 1/2 as a power of 2. That's 2 to the negative 1 to the x is equal to 2 to the 1. And so negative x equals 1 when x is negative 1. Next question, we have a couple other just happy little no calculator log problems. This part, these cannot be combined using the property, by the way, because they don't have the same base, so you can't use the property on these. So log of 1/2 base 4, what's that? Well, what that means is 4 to what power is equal to a half? So how do I make a 4 to a power into a half? The power has to be negative, and that flips it to 1 over 4, and then it has to be a square root to be square root of 4 is a half. So that's going to be negative 2. Or excuse me, negative 1/2. If you rewrite them at the same base, and you rewrite them at the same base of 2, this is going to be 2 squared to the x, the unknown, is equal to, and then 1/2 is the same as 2 to the negative 1. Rewrite them at the same base. When does 2x equal negative 1? That's when x equals negative 1/2. So another way to look at it there, a little more structure. This next question, the natural log of 1 over e to the 7th, I'm going to rewrite that as the natural log of e to the negative 7. And I told you that a tip is if you don't have the base, write it in. If it's one of those bases missing questions, just write it on there. So now we can see a little more clearly that e to what power equals e to the negative 7. So what power would make this true? Negative 7. So the value of the natural log of 1 over e to the 7th is negative 7. All right, cruising right along. 11 to what power is equal to, if you have a radical, change it to a fraction exponent, a rational exponent, that would be 11 to the 1/5. 11 to what power is 11 to the 1/5? 1/5. Okay. So that's another tip. If you have radicals, write them as exponents that are fractions. Here we got 3 happy little log values. We got the purple stuff, we got the red stuff, and we got the blue stuff. And all those are going to have nice little neat little values because this is the way it's meant to work out. So what is the log of 27 base 3? 3. What's the log of 16 base 2? 4. What's the log of 1 base 9? 0. 3 minus 4 plus 0 is negative 1. The value of that's negative 1. Just got to be able to, you want Sabrina? Go ahead. Just have to be able to evaluate those logs pretty quick. So you'd be able to look at log of 27 base 3 and go, boom, that's 3. Okay. All right, last 2 down here. We have just rewriting them in forms. There's a couple problems on the test just like this. Just show us you can switch forms. So in this case, this is going to be the base x to the 14th power equals 26. If you write this in log form, this is going to be the log of 15 base 5 equals x. So just switching back and forth. Okay. Next page. This is the page. These type of problems are going to give people tons of trouble, guaranteed. The biggest thing people do wrong here is they just say, oh, a is 3, and they just put 3 in there for a, and they put negative. No, not a is 3, it's log of a is 3. So you have to break it up into all the separate logs first before you plug in your values. So I'm going to use the properties to separate these logs. This is going to be the log of a plus the log of b minus the log of c. Okay, so if you're multiplying 2 logs with the same base, you're adding them together. If you're dividing, you're subtracting. So now I can make my substitutions. The log of a is 3, so I'm going to take that whole thing, log of a, and put 3 in. The log of b is negative 1, so I take that whole log of b and I put a negative 1 in. So it's plus a negative 1. And then minus the log of c. The log of c is negative 2, so that's going to be minus a negative 2. So here we have 3 plus negative 1 is 2. 2 minus a negative 2 is actually a 4. So that whole expression should be equal to 4. Over here in 20, we have the product property again, but we also have some power property in there. So it's like the log of a squared plus the log of c. I'm going to change this to the 1/2. Yeah, we're logs. I'm recording a video key because I'm going to be at the old wax museum. Remember I told you about that? All right, so this here is going to be 2 times the log of A plus 1/2 times the log of C. And now you can make your substitutions. So what is the log of A? That's above is 3. What's the log of C? They say up there is -2. So that's going to be 2 times 3 plus 1/2 times -2. That's going to be 6 minus 1, which is 5. All right. All right, and this last one here, we're going to have, this one's, I'm going to have to write a little smaller here, log of A minus log of B squared. And then I'm going to just do both minus because they're both on the bottom, log of C cubed. All right. Okay. Sorry. I'm back recording now, so can you please be quiet? Now we pull that 2 down there. So there it comes down, that comes down, like so. So now we have the log of A minus 2 log B plus, just kidding, minus 3 log C. Oops. So what you should end up on that one is log of A is 3 minus 2 times the log of B. That's going to be 2 times -1, so that's minus -2. Minus 3 log C. Log of C is -2, so that's minus 3 times -2 is, what is that? What's 3 times -2? -6? Minus -6. So 3 minus -2 is 5. Minus -6 is plus 6, so I think that's 11. I'm probably making a few mistakes in this video because I'm going really fast, so I'm sure you'll let me know when I do. All right, now we're going to do the other way. We're going to use the properties, write it as a single log, and if you can get it down to a number, great. So this is going to be the log of 5 plus the log of 2, which is the log of 5 times 2, which is the log of 10. What's the base if the base ain't there? 10. So log of 10 base 10, that's just equal to 1. 10 to what power is 10? 1. Okay, next one, we got a number out in front, so that's actually can be an exponent on the x, so that'll be a x to the 5th. We got a 2 out here, so that'll be a y squared. So we can put both these natural logs together. They both have the same base e, and that's going to be a divide because it's subtract, so we use the quotient property. X squared over, or x to the 5th over y squared. Can't do anything left with that. Next one, we have 7 log of y, so this is going to be like a y to the 7th. That 3 is like a x cubed, and that 4 is like a z to the 4th. If it's minus, you put it in the bottom. If it's plus, you put it in the top. So we have the log of y to the 7th times x cubed all over z to the 4th. And z is in the bottom because it was a minus. So the minus stuff goes in the bottom, the plus stuff just goes in the top. So it's just a log of all that stuff. Over here I have some numbers. So the log of 96 base 2, that's not a power of 2. But maybe it will be after I divide them because they both have the same base. So I can put them together and make it 96 thirds base 2 because I'm subtracting, use the quotient property. 96 divides by 3, I believe that's 32. So really this is like saying the log of 32 base 2, and that's a happy little math book problem right there. It works out nice, neat, and friendly little problem. 2 to the what power equals 32? 2 to the 3rd is 8, 2 to the 4th is 16, 2 to the 5th is 32. That's going to be a 5. Brilliant. Brilliant! Okay. How are we doing over there on checks? Good? All right, next we got log. We got some equations to solve. This would be probably a no calculator. Or no, well, let's see here. Might be a calculator or no calculator. Let me check. Next page is calculator. So this would be no calculator stuff still. So no calculator on these. Log of x plus 5 base 4 equals 3. if you're stumped on a log equation, just try to change it from log form to exponent form. So this is going to be 4 to the third equals x plus 5. Oh, I know what that is. That's going to be 64 equals x plus 5. Hey guys, what number when you add 5 to it do you get 64? 59. Yep, you're right. 59 plus 5 is 64. Got it. Yep. Okay, next question. We're going to have to use a little property on this one. See these two, log x plus log 4? We can make that log of 4x using the product property. So log of 4x equals log of x plus 4. This equation is log equal log. The previous one was log equal number. So if you have log equal log, you know what you can just do? Just drop off these logs as long as they have the same base. Right? Drop logs. Right, Mr. Dahl?
Drop log. This morning.
Drop log. Oh boy. That was actually the joke I was trying to set up anyway. Dropping logs. So now we got x plus 4 equals 4x. You're going to subtract one of those x's to the other side. That's going to be minus x there, minus x there. You're going to end up with 3x equals 4. 3x equals 4 on the left rail. Preakness this weekend. 3x equals 4. That's x equals 4/3. I believe it's 4/3 on this one. Ta-da! All right, let's keep cruising along. Let's get these two done. This, let's see, a 3 out in front. Could I divide by 3? Well, you know what? This is also an exponent. I don't think 125 is divisible by 3. And there's nothing out in front of that log anyways. That's not really going to help because I don't have a calculator. So dividing by 3 would be kind of a stinker because then I have to do the log of 125 base 10 divided by 3, and then I don't really know what that is because I don't have a calculator, and now my smart board's giving me trouble, so I'm going to rip it off the wall. So don't do that. Oh, crime in Italy. Ah! This thing is just a PO. All right, let's see how much funny. Yeah, that's real funny when it jumps around like that. God bless America. Okay, it's going to do it again. X, ooh, nice. X cubed, this 3 is a exponent, so put it back up where it belongs up there. So now we have the log, we have the log of x cubed is equal to the log of 125. Holy crap! No pun intended. What do you do when you have the log of both sides? Drop logs. All right, drop the logs. We have x cubed is equal to 125. Okay, how do I get rid of something that's cubed? You could say cube root, or you could say to the reciprocal power. We've been going reciprocal powers. So both sides to reciprocal power. The 1/3 power is the same as cube root, so x equals 5. Ka-chow! Next question, we got 2 logs. We can put them together with the properties, make it 1 log. That's going to be the log of x, 4. Look at that, that's a sweet 4. 4x squared minus x. Oh, it's a quadratic. How'd I do that? I took this x and I distributed it because I have to multiply it by that stuff right there. So 4x squared minus x equals 1. Okay, that stuff equals 1. What's the base? 5. Okay, now we have log equal number. Rewrite it as an exponent. So that's going to be 4x squared minus x equals 5 to the first power, which is just 5. Subtract 5 to the other side. I get 4x squared minus x minus 5 equals 0. Okay, that should factor, hopefully. So let's try to factor that up. We got factor. Factors of 4x. I'm going to go 4 and 1. So I'll go 4x and x. And then 5, I'm going to put the 5 all by itself. So I'm going to put the 1 here and the minus 5 there. Let's check my outside products is going to be 4. My inside is negative 5, and that adds up to negative 1 in the middle. Whew! So there we go there. So what makes that 0? Opposite of 5, negative 5 is 5 over 4. What makes that one 0? There's supposed to be a plus there. That's going to be a negative 1. Don't forget to check for extraneous. And you know what? I think this negative 1 is going to be extraneous. Yep, because when I put a negative 1 right in there, it gives me negative stuff. So that's not actually a solution, that's extraneous. So my only answer here is 5/4. Phew, all right, next page. Okay, we're on to the calculator stuff now. So if you have a variable in your exponent, you want to get solve for that. That's why we do logs. That's what we do logs for. So rewrite it as a log. That's going to be the log of 106 base 17. Now if you have a fancy calculator, you can just plug that right in there. If you don't have a fancy TI Inspire, then you're going to have to use a change of base formula, which would be log of 106 divided by the log of 17. Okay, and don't forget to have log on top and log on bottom. That's what students forget a lot of the time, and then they end up getting the wrong answer. So that's going to be log of 106 base 17 to my calculation is 1.65. Okay, next same question, but we got a little stuff to undo after we rewrite it. So we rewrite this one as the log of 295 base 15 equals 3x minus 2. Okay, but I want to solve for x, right? So I got to get rid of some stuff. So I want to get rid of the 2, so I add 2 to both sides. And then I want to get rid of the 3, so then I'm also going to divide both sides by 3. And so when I clean that all up and I'm all said and done here, I'm going to have x is equal to the log of 295 base 15 plus 2, all that divided by 3. Put that in your calculator, hit enter, and you will get, let's see, plus 2. That divided by 3. I got 1.37. Okay, next one we have a 5 times e to the x equals 43. This one we can divide both sides by 5 to get rid of that 5. Okay, so now we have e to the x equals 43/5. And so now if we want to solve for a exponent, that's why we have logs, right? So rewrite it as a log, but I'm going to rewrite it as a natural log because it has a base of e. So the natural log of 43/5 equals x. And of course the base is e because I used the natural log. So now I have the natural log of 43 divided by 5, 2.15. Okay, number 28, what's the base when the base is missing? You're going to say at home 10. So write that in there. Change this to exponent form. If I don't know what to do, change forms. Oh, I change forms and look what happens. 10 to the 0.46 power equals x. I just type that in the calculator. There's a button for 10 to the x. It's right on top of the log button here. 10 to the 0.46. 2.88. Bada bing, 2.88. There we go. Next question. Natural log of x equals 1.44. I gave you a tip. I said if the base isn't there, just write it in. Oh, now I know what to do. Change it to exponent form. E to the 1.44 power equals x. Hey, there's a button on my calculator for that. It's right next to the natural log. E to the 1.44. That's going to be 4.22. All right, so that one's 4.22. There we go. Next question. We are solving for a base on this one. So rewrite it as an exponent. Again, I have x to the 4th equals 30. All right. How do I get rid of it to the 4th power? Take it to the reciprocal power, which is 1/4 on both sides. Okay, x to the 4th to the 1/4 is just x, and 30 to the 1/4, I typed that in my calculator. 30 to the 1/4 power. Wow, I'm going really fast, huh? I'm starting to become winded. Let's see what my heart rate's at. 86, wow, that's pretty good. All right, 30 to the 1/4 power, that's going to be 2.34. Okay, next question, we have the log of cube, let's see, log of square root of x and base 3. I'm going to take the square root of x, I'm going to write it as to the 1/2. So I'm going to rewrite it as an exponent. it's 3 to the 2.4 power equals x to the 1/2. But I don't want x to the 1/2, I want x to the 1. So I'm going to get rid of that 1/2 power by taking both sides to the reciprocal power, which is reciprocal 1/2 is 2. All right, so now I would have x equals 3 to the 2.4 to the 2. Well, it's a calculator question. I can just type that right in. But a power to a power means that it's actually to the 4.8 power as well. So 3 to the power of 4.8 equals 195.01. If you want to double check and see, I don't know, is that right? You could just type in 3 to the 2.4 power and then take that to the second power and you get 195.06 blah blah blah. Oh, 0.1, it actually should be 0.6 or 0.7. There we go. All right, phew, last question. Use a little log property here. Combine those natural logs to make the natural log of 5x is equal to 1.3. What's the base of the natural log? E, good. Rewrite this as an exponent. It's e to the 1.3 power equals 5x. I don't want to know what 5x is. I want to know what x is. So get rid of that 5. Divide both sides by 5. So your answer here is going to be x equals e to the 1.3 power, all that over 5. Put that in your calculator. You go e to the 1.3. Take that stuff, divide it by 5. You end up with 0.073. So 0.73. Phew, we did it. Thanks for all the cooperation in here. Whoa, the bell just went. Holy crap. All right, happy studying.